Hello everyone, welcome to Digital System Design Laboratory. So initially I explained how to install Arduino and Proteus and the integration of Arduino libraries in Proteus environment. So today we are going to learn what is Arduino and different types of Arduino boards and their features and which boards we generally use. Then basic R system, their pin layout. Also, we learn about Arduino IDE software, where we generally run the code that is needed for Arduino board. And then we will focus on two tasks, two simple project, I can say. And at the end of today's lecture, I will explain a homework for you. So now, what is Arduino actually? So I think you already know microcontroller. In previous course, you already learned about microcontroller. So there are different types of microcontroller. This could be Atmega 328, Atmega 328P, Atmega 1260. So there are different models of microcontroller, and when you want to perform some task using microcontroller, you need other devices. For example, you may need a crystal oscillator. You also need some resistance, some capacitance, and other things. So with using only microcontroller, you can't use it in any project. You need other devices with it to work with microcontroller. There comes the Arduino. Arduino gives the facility. Arduino is actually microcontroller plus other components that we generally need with microcontroller. For example, if you notice here, this is actually a Arduino UNO board, the front view of Arduino UNO board. So this is the main microcontroller, and if you want to work with it, you need a crystal oscillator, which is given here. This is a crystal oscillator actually, and there are other different, let's say here, capacitance, or also some resistance and other things. This is more like a PCB, right? Printed circuit board, where microcontroller and other peripherals are already connected. Here the power source. This is the DC jack through which we can give the power that is required for Arduino, and this is the a port through which we can connect Arduino to our laptop or computer through USB. So all of these things are integrated in this board, so that we don't need any of this separately. So if we want to use microcontroller, then we need this sort of power jack management. Also, programming the microcontroller is tedious as compared to programming of Arduino. So there are different hard jobs. If we want to perform our task in microcontroller, Arduino gives those facilities. That's why if we have this Arduino board, then it is quite easier to perform any of our projects. So that's why the Arduino. So I can say Arduino is actually a microcontroller based development board. So everything is there. If we want to perform any sort of projects, it is quite easier because all are there. Now different types of Arduino boards. So Arduino UNO R3 is the most common board. It is the most common. According to Arduino website, they have mentioned that people generally start their projects or work with Arduino UNO. So this is the most common, and as I already mentioned that Arduino is basically based on microcontroller. So Arduino UNO is based on Atmega 328P. So this is the Atmega 328P microcontroller. And there are different GPIO pins, that means general purpose input output. So these are digital pin. Here starting from 0 to 13, we have 14 digital IO pins for Arduino UNO. So along with this digital pin, there are also some analog pin here. If you notice, A0 to A5. So these are analog pins and these are digital pins. So I think you know what is analog and digital. So analog actually take any values. and in our cases it will take any values from let's say you are using analog pin, you are going to read some voltage value from 0 to 5 volt. So this voltage could be 5 volt, 4.9 volt, 4.98 volt, 4.6 volt. So there are different values, and this is analog quantities. So if you want to read this type of values, then obviously analog input pin will be your choice. Whereas let's say you want to perform some operation where you just turn on an LED or turn off an LED. So you just need high signal, that is to turn on, or one logical one I can say, or plus 5 volt I can say, or low signal, that can I say zero, logical zero, and it could be 0 volt. So if your configuration, if you need this type of configuration, obviously digital pin will be your choice, since digital generally works with two state. One is logical 1, another is logical 0, that is true or false, or I can say high or low. So digital pin basically works with this functionality. So when you need digital values or two state, one is binary 1, one is binary 0, then obviously uh, digital pin will be your choice. Otherwise, if you want to work with analog values, then obviously analog pin would be your choice. And another thing, if you notice, PWM digital IO pin. So with these 14 digital IO pins, if you notice closely here, so there are some in front of some pins there is a tilde sign, and here it is written this tilde sign represents they have PWM capabilities. So what is PWM? I think PWM means pulse wide modulation, right? So pulse wide, let's say this is a signal, and the wide of the pulse, this is the wide of the pulse, and this wide is modulated. So then comes the duty cycle. So this signal is more of 50% duty cycle. That means 50% time it is on and 50% off. So if I make a total 1, that is 100% duty cycle. That means all the time it is giving a 1 value. Let's say it is logical 1 value. So by using these facilities, you can control the brightness of an LED, let's say. Also, you can control the speed of a DC motor which is connected to Arduino board. So whenever you need this sort of operation, when you need to control the voltage level, output voltage level, then obviously PWM pin is a great option. So this PWM pin, we will work on this later. So in Arduino UNO board, as is written here, among these 14 digital IO pins, we have 6 pins that have PWM capabilities, and it has 6 input pins, analog input pins that I already mentioned, and the crystal oscillator or the clock speed here is 16 megahertz. And another feature which is the built-in LED. So if you notice here, this one is actually a built-in LED. So built-in LED, that means you don't need to connect any LED. If you want to check whether the Arduino board is okay or not, you can just write a program which will executed to show whether the LED is blinking or not, let's say. So then you can use this LED built-in. In our previous video, I showed you that there was a code where it is written LED built-in, and I mentioned that I will explain it later. So this later came now. So LED built-in, that means this pin number 13. That's why in our previous circuit we connected an LED, an external LED, since in our Proteus we don't have the built-in LED. Proteus just giving some simulation facilities, and it is not the full Arduino board. So that's why the built-in LED is not showed in the Proteus environment. Anyway, so to demonstrate it, we have connected an LED with pin number 13 like this in our previous experiment, and then there was a register and these sort of things. And in the Arduino code we have written it as LED built-in. Since LED built-in means 13, that's why we connected it to 13 number pin. So some other things in this Arduino board, I think all are mentioned. Okay, so now if you notice here, this is the reset button. So whenever you press this button, this push button, then Arduino board generally restart. Okay, so this is the reset button, and sometimes we need this whenever we found any anomaly, then we generally give it a reset, just like our computer restart. Anyway, and here is also a reset pin. So using this reset pin, this could be active low or high. You should watch this from data sheet. Anyway, so by using this reset pin, you can also reset the Arduino board with proper signal. And this 5 volt and 3.3 volt, which generally denotes the output. So for example, you need a plus 5 volt. So what you can do, you just connect an wire from here, so obviously you will get plus 5 volt. And let's say you need 3.3 volt, so you basically connect it from here. So these are just if you want these voltages, you can take as connection from here. And the next one, V in here. So I previously mentioned that through this power jack, DC jack, you generally provide the power for this Arduino. Also, when it is connected to PC through this USB, then obviously the Arduino board will take power from PC. So when it is not connected, then you may give power through this DC jack. Also, this V-in is a good option. Then through V-in you can give required amount of power. So you just connect some male pin here, so it will be powered one. So there are 3 ways to give power to this Arduino board. And another thing here, TX, RX. So these are transmitter and receiver pin. So for example, you are connecting Arduino with an Bluetooth module, let's say. Then obviously the Bluetooth module have some similar TX and RX pin. So this TX will be connected to the RX of Bluetooth, and the RX of Arduino will be connected to the TX of Bluetooth, and obviously this will be connected through wireless, since we are talking about Bluetooth. Anyway, so these are the pins that they will be communicating. So there could be different number of TX RX pin, and for Arduino UNO we have only one pair of pins for transmitter and receiver. Also we can use any other pin as TX RX, then we need to write something different in your Arduino code. Anyway, that's a different part, I'm not talking right now. So I think I mentioned the major components in the board.